Right, good afternoon, my children. Thank you so much for joining us again on this Monday evening. Last week we did discuss some redox reactions, looking particularly at the galvanic cell in a little bit more detail. We did make mention of the two cells that did exist, of course, and we looked at which half reaction takes place at which electrode. Recapping, a galvanic cell we know has an anode and a cathode. The anode, in just a sec, the anode we know is negative, and we know that the cathode that is positive. Okay. Another thing we do remember is that the half reaction that takes place at the anode is, of course, the oxidation half reaction. And we know the reaction takes place at the cathode is obviously the reduction half reaction. Okay. Another thing we also touched on was that the anode, this does decrease in mass. Alright, so the mass decreases, and we know here that obviously the mass increases at the cathode. Excuse me. Did I miss a S there? Well, my tablet won't allow me to go further than that. Should have actually written a bit closer. Anyway. Alright, that's what we mentioned. We obviously know that there's a voltmeter that is hooked up to the electrodes on the other side. We also know that there's the presence of a salt bridge. Okay, the salt bridge, of course, main function that every student remembers and every teacher remembers off the top of their head is that obviously it completes the circuit, and an extension of that, if you choose to remember this first, of course, because this is by far the most obvious answer that every single student, I've seen it when I was at school, and I've seen it once I've left school, ever since I started tutoring the subject, is that they always write this, but the understanding behind it and the reason why it completes the circuit is because it allows the electrons, or ions rather, to pass through. It's a path, of course, for the ions to pass through, and that's if the salt bridge wasn't there, the ions wouldn't be able to move through. So that's the main function, completes the circuit because it supplies the path for the ions to move through. Another function is that it separates the electrolytes so that the electrolytes itself don't mix. So that's the galvanic cell that we looked at last week. The next thing that I want to look at today to begin our session, okay, is something called, let me just undo that, is something called cell notation. Just change color. Okay, something called cell notation. Okay, now cell notation is very interesting. Okay, it's similarly likened to that of inorganic chemistry. There's more than one way to obviously represent the structure of an organic compound or molecule. Okay, we have structural formula, okay, which is very graphic and very drawn in detail, whereas we have condensed structural formula as well. So cell notation kind of provides us with an easier way of writing down the reactions that do take place at each or either electrode. Okay, so let's have a look at what it actually is. And cell notation works well with galvanic because it's the shortened cell notation that represents in particular to the galvanic cell. Now if we have a look, there is a general formula for it. So how we write cell notation starts like this. So we have first we have the reducing agent, and I'll show you an example in a moment. But we have the reducing agent that's written first, separated by a straight line like this. Then next is we have the oxidized, either we have it's called the oxidized species or substance. Okay. Then we have a double line present, and I'll explain the double line in just a momento. Okay, I'm going to fit all this in. We have the oxidizing agent. Now, let me write that better. Agent. One more single line, and we have the reduced species or substance. Okay, that's one way to look at it. Or you can write it such that we have a anode. So we have an anode. Line didn't want to straighten. Then we have something called the electrolyte in contact with the anode. Electrolyte in my tablet doesn't allow me to go further than that, so I'm going to write it like this: in contact with the anode. In other words, the electrolyte that has made contact with the anode, what is actually at the anode. Bring that a little closer. There we go. Salt bridge. And then we have the electrolyte in contact with the cathode. Electrolyte that's in contact with the cathode. And then of course we have the cathode itself. Now let's have a look. Again, the side's negative and the side is positive. So let's have a look at a particular example. Pick that color. Okay, so let's say we have the zinc copper galvanic cell, which is by far the most common galvanic cell asked and represented in a exam, as well in textbooks for understanding purposes, of course. And this is an active electrode. In other words, the voltmeter is connected, reactions are happening, so it's active. In other words, that ions are passing through. So active electrodes, ions are passing through, the reactions are happening, they are taking place, etc., etc. Let's take a look at example with the zinc. So we're going to have a look here. So the reducing agent, all right, the substance that gets oxidized. So I have my example. Bring that up. Sorry, let me just fix that. Example. I have my zinc. It's solid because it's the at the anode, separated by a straight line going down like that. And the oxidized species is that what does it become after it's oxidized? It becomes Zn2+. It's lost electrons, separated by the salt bridge. Okay, and oh, I forgot to put that these ions obviously are now in aqueous solution because they are now in the electrolyte. This is the salt bridge, this double line over here. I'll put it over here. This is the cell notation for the salt bridge. Okay, so aqueous solution, and then now the oxidizing agent. Obviously, the oxidizing agent is the substance that's going to get reduced. So that will be the Cu2+. What is it reduced to? It's the gain of electrons. Becomes, oh, that's an aqueous solution as well, becomes Cu solid. And that obviously over here we have the negative side, so we put the negative either at the bottom or on top, and you obviously have the positive side at the bottom or on top. Okay, this is for your active cells, or active what I want to say, the active electrodes. That's the word I'm looking for.